Hey guys, today we're doing angle bisectors, and if you watched the last video, you know that a bisector cuts something in half. Last time we looked at perpendicular bisectors, which was a line that cut another line in half at a 90-degree angle. Angle bisectors go through an angle, splitting that angle into two equal angles. Once again, we're going to learn 4 methods for constructing an angle bisector. Starting off with the low-tech paper folding. Again, paper folding is not the easiest, but it works, and it takes no technology, just your paper with the angle on it. There's one key difference for using paper folding to construct an angle bisector compared to doing a perpendicular bisector. If you remember, in perpendicular bisectors, you had to match up the endpoints. In angle bisectors, you do not match up the endpoints. You probably won't make an angle bisector if you match the endpoints up. This one is really tricky. You have to get the crease to go right through the vertex of the angle, or the corner of the angle, so the crease has to go right through that corner, and you have to get the lines to match up perfectly if you can. So I would say that for a perpendicular bisector, you can be pretty precise when you're paper folding. With an angle bisector, it's harder to be as precise. Let's give it a try and see how it's done. So, 2 parts of paper folding are tricky. One is getting the crease to go right through the vertex, and the other is to overlap the lines as you're folding. Notice how these 2 lines are different, slightly different lengths. This is why matching up the endpoints won't work. So if I match up the endpoints, the fold is going to go nowhere near the vertex. It's going to end up about here. In order to get the fold to go right through the vertex, I'm going to put my finger on it to try to get the crease started at the vertex. I've got a start of a crease right there. Now it's a matter of lining the arms of the angle together. Try to pin them close. If you think you've got them lined up, try to pin them there while you make your crease permanent. Hopefully through the vertex. So it might not be perfect, but it looks pretty good. I got it almost directly through the vertex, and these 2 angles look like they're about the same size. If I wanted to check how well I did, I could take my protractor and measure the 2 angles. If they're the same size, then I successfully bisected the angle. I decided to check my work, and as it happened, even though I just drew a random angle without measuring, it actually was almost exactly 80 degrees, and I did a really good job doing paper folding because both of these angles were almost exactly 40 degrees. So as you can see, it is possible to do this accurately. The second one is probably the one you would have thought of if I asked you to bisect an angle or cut the angle in half. You probably would have pulled out your protractor, measured the angle, and divided the number of degrees in half. And that's exactly what we're going to do. The aimer will go directly on the corner of the angle, or the vertex of the angle. You're going to line up one of the arms with the 0-degree line, and you're going to measure the angle using your protractor. That'll give you the number of degrees. You divide that number of degrees in half, then you mark a dot at the halfway angle and draw a dot through the vertex and that dot that you marked at the halfway point of the angle. Let's try it out. This is the method you probably would have done if I just asked you to bisect the angle or cut it into 2 equal pieces. I'm going to get out my protractor, make sure the aimer goes on the vertex. Line up your line, one of your arms with the 0 as I'm doing here. And this 0 is on the outside, so I'm using the outside numbers to measure. This one is slightly less than 50. It's about 49 degrees, which means it's basically going to be 25. I'm going to make my mark slightly behind 25 at about 24.5. And I'm going to draw my line through the vertex and the dot that I just made. Should have been a bit more careful there because my line is slightly off of the vertex. If you're not sure how I got the number 24.5, I measured this, and this was 49 degrees, and if I divide 49 in half, I get 24.5. So I tried to make each of these angles 24.5. Next up, we're going to use our compass, and for this one you have to draw 3 circles, or parts of circles. You're going to start off with the compass point on the vertex of the angle, and you're going to draw a circle that goes through the 2 arms of the angle. Once we have that, it gets pretty easy. we move the point of our compass to where the circle intersects with the arms of the angle. We're eventually going to end up with a shape that looks sort of like the one we had when we drew the overlapping circles for the perpendicular bisector. Put the compass on each arm. Put the compass on each arm of the angle where the circle intersects it, and you draw a circle that goes through the vertex. If you did your first circle properly, it should go straight through that vertex. Move it over to the other side, draw a line straight through the vertex again. This is a lot easier when you see it in action, so let's take a look. When you're using your compass, you can set your arms as far apart as you like, as long as they're not bigger than the arms of the angle. Technically that would still work, but then you'd have to extend the arm and it would just make it more difficult. So choose a comfortable distance so that it's something that you can easily draw circles with. And what you're going to do is you only need the parts where the circle would cross, like this. So I'm just moving my compass across like that to mark that. But it's okay if you want to. You can make that full circle, but you don't need any of that stuff. I only need the place where it crosses the arms. I keep my compass set the exact same length, and I move the point to one arm. I draw a curve through the vertex, like that. And then I do the exact same thing on the other side. Move my compass to the other arm, and this line should also go through the vertex until it crosses that other curve that I did. So you can see we've seen this shape before when we did a perpendicular bisector. Now all that's left is to draw a line through where the two circles intersect and the vertex of the angle. And again, if you want to, you can draw this through. The line doesn't have to stop in front. Most people stop it at the vertex. You can go through just as easily. And what's cool about this is it actually also bisects this angle on the back too. So these two angles are also equal. The last method is using a triangle, and this one is often found to be pretty tricky. In your geometry set, you have two triangles. I strongly recommend using this one. You can use this one, but it usually is quite a bit more difficult. When we're using a triangle to make the angle bisector, the key is to line up this point with the vertex. Basically, we're going to trace the 90-degree angle here twice, once on each arm. When you're doing this, you have to make sure that the 90-degree angle is away from the vertex. So you're going to put this point into the vertex, line this up with the arm of the angle, and then trace this line up here. Then we're going to flip the triangle around and do the same thing. We line this point up with the vertex of the angle, line this, put this point on the vertex of the angle, line this up with the other arm, and trace this angle. Then you're going to have two lines that cross each other. Then we're going to draw a line through the vertex and where those two lines cross. I think it'll be easier when we see it, so let's take a look at it. People often find this method with the triangle a little tricky. One of the confusing things about it is that you have to use your triangle upside down when you do this. So to start off, I'm going to line this angle up with my vertex, making sure that the right angle is the farther one away from the vertex. Then I'm simply tracing the triangle to make a right angle off of that arm. I'm going to do the same thing on the other side. But here's where people get stuck. They try to put their triangle on and they can't figure out how to do it. You have to actually flip it upside down. You can see that the writing is backwards now. But then I do the same thing. I line this up with my vertex. Make sure that this edge is aligned with the arm. And then draw your line up along. And as you can probably guess, all that I really care about is this intersection. Then, all that's left to do, draw a line from the vertex through that intersection point. And there we go, we bisected the angle using a triangle. That's it, that's 4 ways to construct an angle bisector. And that's it for our geometric constructions part of the unit. I hope you found the video helpful. I'll see you next time, if I make any more videos.